Okay. Education round 120. This is not rated for me, but if it's rated for you, good luck. I don't know what else is in it. Let me get some water. Um, and yeah, contest is about to begin. A rectangle. Isn't that just... So we can do something like this, maybe? Um... Is it just yes or no? Problem A. Crap. 615. Why is this no? Oh, because you don't have to split it evenly. Wow, I'm stupid. Hold on. Okay, I'm actually very stupid then. Oh, we want to brute force a stick that we want to break, right? This is a stick that we break. And these are the sticks that we don't break, basically. Our option is either... Well, I guess this is an equivalent option. Then otherwise... Oh, else I get 0 plus else I get 1 is equal to array at B. Because then we can just split it like this. Okay, let's try again. Okay, we got it. Let me open up a complete problem set. Let me just also... Yeah, that works. So you're a music streaming service built specifically to support Berlin, something. Oh, okay. Node P is a permutation. Wait, the ice song is a predicted rating equal to this. Oh, okay, it's a permutation. And the one that has the smallest... Okay. So you just put it into two groups, right? And they just form like a prefix and a suffix. Like the permutation in a bit string, basically. So we do something like this, and then, okay, if it's a song that's not liked, then it has to go before the songs that are liked. Do we just sort them in that order though? Can we just do that? No, because it's like, if it's a group like this, yeah. I guess it's like we can put them into two categories, right? It's like we first put them into odd, like, oh, okay. We do this. Frick. If this is equal to this, then 0 is not add. You don't care about the location, right? I don't think you do. Okay, where is each value located then? Location, array I, what I. So do this. Do you want to do in decreasing order? Yeah, we want to do in decreasing order. Yeah. Okay. Right? Because if it's a difference. If there exists some value C, D, if we know that A is less than B and C is less than D, then it's like A minus C. Like no matter where it is on the number line. Then that would be worse. Then this would be the same. Yeah, either always the same or it's worse. So yeah, that's why. What do you do here? Well, I started to value n, I guess. Or not even value n, but how do I implement this? So we have where all the zeros are, what the value of all 0 things are, value what all 1 things are. We also have the original array. this is not the best way to do it, but this is a way to do it. So I'm just going to go with it. So if I is less than 0 prefix dot add I, alpha suffix dot add I, collections dot sort prefix okay, so if we do this, oh, but we need to know the location, right? We need to sort them by this. X, Y. And we need to sort them by this, and then we don't need to reverse these anymore. So that is fun. What's not fun is why this isn't working. What's wrong with this? What if I just run this and see what happens? Oh wait, oh, okay. And then over here, same for suffix yar. So res. Oh wait, no, res prefix dot get. So this is the location of the largest element. This will show the location. This will give the actual largest element in zeros. Okay, and then we do. Line 65. Oh. Two, 1, 3, 1, 2, some random permutation. Let's just assume it's right. No. Oh wait, what? There's a like song that's rated lower than a dislike song. Wait, how is that possible? What? We know the ratings for dislike song, for the like songs are 1, 2, 3, 4, 5. Oh wait, hold on. And val is equal to 0 dot size minus 1. No. I think I'm just stupid. Where val is equal to n. So was zeros and ones just useless? Is that basically what happened? No. 2, 3, 1. There exists a liked song that's lower than a disliked song. Wait, so 1 means it's liked, right? Yeah. So these liked songs should go. Well, disliked songs should be 1, 2, 3, 4. Okay, wait, prefix is where all the zeros are located. And they're sorted in this order over here. So among where all the zeros are located. So it's like this song is a disliked song. This song is a liked song. Wait a minute. Two. Wait, that's not what? Wait, that's literally not anywhere where anything is located though. Is it supposed to be like it I is equal to 0? And prefix at I? I feel like that might be why. That makes a little more sense. 165832447. Okay, that's a valid permutation. Okay. That took way too long. What is wrong with me? Oh my god. Okay, problem C. Okay, so we either decrease AI by 1 or we set AI to be this value. So we always want to do the decrement values first, the decrement operations. The sum of entire array can be at most 10 to the 14, I think. Or like roughly that, I guess. So if it's like... Okay, we can just binary search. It's like we want a minimum number of steps we need. Oh, if we sort the array, then you always want to make the biggest elements go down that way. Okay, so if we do this, first thing to do is to sort the array. Wait, hold on. For index array, res. Wait, so minimum number of steps to make this less than or equal to k. So it's just sum minus k. Well, max at 0. Then this. When I is equal to. I guess these are showing. These show elements that we remove. Or like we turn into the minimum. Yeah. We don't need to turn the minimum into itself, so. Long suffix. Okay, so while. Wait, so long low is equal to 0, long high is equal to, I guess, sum minus k. So long low is not equal to high. So okay, no, we'll show the minimum value that, because okay, so array at 0, low is equal to array at 0 minus, because if we just subtract everything, wait, sum minus k. So if sum is less than or equal to k, then we can just do this. Okay, so now let's just assume sum is strictly greater than k. Because, okay, if we subtract it by this, then it's guaranteed to be okay. And the bound of this is about 10 to the 14. Wait, so if we represent so n minus r minus 1 is 1, that's 2. Okay, so if this is like the new value basically, Okay, so this is... So in other words, we get two mids. So it's n minus a plus 1. It's two values that become mid. Minus array at 0. Minus prefix. Or suffix, I mean. This is how much it changed. And so if sum plus delta is less than or equal to k, then mid is good enough. Else we need to make mid lower. A minimum of res, and then basically the first thing we need to do is to do this many operations to make these values that. And then we do array of 0 minus lower number of operations. Ten, 0, 2, 7. 10, 0, 3, 8, frick. Third test case, so you can set set these values to be 1. So this is equal to 1. Wait, the sum of this array is currently 4 plus... Wait. Okay, went down by 2, then went down by 1. So it would have been added, so it would have like added 3. That was like the new smallest number. -2. -2 is okay. Low in this case should be equal to 0. But clearly not. Okay, so if mid was equal to 0, it would be negative array at 0 minus suffix. Or it's like you turn it to 0 first, right? And then you assign the value to here. But if you turn this into 0, and then A3 will become that. And this one will also be a 0. Yeah. There's like some minus a suffix minus some smallest element. And then in return we get mid. Now sum of this array is 4, 7, 8. That's 11. So if it's 11 minus I forgot to sort this array. Wow, I'm stupid. How did I forget to do that? I literally imported the... I even like put the function in here. Well, okay. Okay, we got C. Yeah, D is the next problem to look at. Okay, you're given a binary string of length n. You can perform the following operation on the string at most once. Choose a substring having exactly characters, one with it, and shuffle. Okay, so if we do like an n squared dp, for example, total number of ways for this whole string to happen. If we can shuffle some range, nk, then this. Okay, so if there's some prefix and some suffix that's unchanged, then we can't just like do that because that will overcount. But if that overcounts, what's the best way we could handle it? Okay, so what if our substring looks something like this? And k is equal to 3. Then basically we have 5 options, but if k was equal to 3, then a 1 would already be over here. And then anything would be over here. Okay. So it's like given a range, the ways you can transition into here is well, no matter where we put the 0 in here, the only way that's like new is if the digit on here is different. So we have to count the number of. So essentially swap this digit and then count how many ways there are to do it in here. And then that would guarantee to be a different way. Does that apply if it's also zeros? Yeah, it is. Okay. Wait, so how many states do we need then? If it's like a number of like ways in total, right? It's like 1 times as many ways. It's like however many ways exist, like however many different substrings exist. Oh, we know, but if that digit is different, that's already guaranteed to be different from anything that we've already encountered from a smaller range. That's not true, actually. Is that true? Wait. I'm a little confused. So it's like. It's like no matter how we rearrange it. Wait, but if we get like the biggest chunks, then that would also work? No, but it also depends on like where the zeros are located. It also depends on where the zeros are, like end up at. What if you just do like So if we do this, the number of ways I can get this entire string to be rearranged. Oh, it's exactly K. Okay, okay. Right, okay, okay. Exactly, okay. That makes more sense. Because I was a little confused. It's like, okay, I thought it was greater than or equal to k. Yeah, that changes the problem a lot. Because you can't shuffle a range that has all these ones in here. Hmm. So now it's like, one way we can think about it is okay, if given a certain zero, if it can end up at point A and point B, it can end up at every point in between. Um, I mean, if it's part of a sub, if it's part of its range, if it can go from A to 0, it can be rearranged any way we want, so it will go in between. And from 0 to B, like the location of 0 to B, um, same thing. Okay. So for each 0, we can kind of figure out between like how many ones it can be placed in. So if we have n ranges of where zeros can go, count the number of ways. Hmm. We place that at 2, then it's like one misplaced. Is there a better way to do this? Probably is, given how easy it is. Okay. What if we think about them like in blocks of 0? So it's like if we do this, because if it's exactly 2, we don't want to keep it its own state. Only yeah, Because it's like, we can do this. The number of ways this overlaps. It's just a number of ways zeros can be contained in both arrays after a shuffle. So like this, which is just this plus choose this minus number of ways for these zeros to stay here. Yeah, because like 1 1 0 0, 1 0 0 1. In terms of an overall string, I guess there's 3 ways that could change, or like it could stay the same. So it's 1 2 3. What if we can change 3 ways? It's probably DP though, right? That's not DP. I'm gonna just check his memory limit real quick. Wait, okay. If it's that, he's not using any memory though. So it's probably not DP then. Or at least it exists way too stuff DP. Does this way work then? If it's just like we count the number of ways for zeros to be like overlapped, because like they can only because if it's exactly k, then they can only be overlapped by, I guess, 2 different intervals. That's not true. They can overlap by more than that. So 1 1 1 0 0 1 1 1. Yeah, because if it was 4, they would be overlapped by 3 different intervals. And a number of ways to do this so that it's like it also depends on which zero it's affected by, in a sense. Okay, well, if 0 is only affected by one thing, oh wait, hold on. Maybe it's like 4, and like these get subtracted because they conflict with each other, and then these get subtracted because they conflict with each other. But that double counts this section. And like the total number of ways to do this is this plus this. Minus this, minus this. The total number of ways to do this minus this, and then it gets overlapped, and then these overlap with each other. So it just gets really messy. This operation at most once. Okay, so if we do DP on like some a range, I guess. If they both end in zeros, for example, then we can just shrink this range, and it's also a range of exactly k. But what that also means is that these zeros won't change. And so for each endpoint, it's like either 1, 0, either changes or it doesn't. I guess we're just like a number of new ways, yeah. I guess we can try this. Do we need factorial? The number of distinct substrings that exist is always just 1. Int length is equal to 2, length is less than equal to n. For an a is equal to 0, a plus length. And a is less than n minus length plus 1. So it's like if you look at a range one smaller than it, then it's like if this is a 0, number of ways in here is already counted by this. Number of extra ways we get is just number of ways such that 1 is forced. And then if we get some other range, I guess. Then it's just total number of ways in there. Wait, so does this work then, or no? Okay, but what if like a 0 and then a 1? Then we just count. 0 to n minus 1. Number of different substrings. Wait. Oh, it's just if it's greater than it. Query. Okay. So if well, today's not my day. Good God. Oh, some range has greater than k. There's many ways to do it. Then it's like maybe we could reduce it like this into either this range or this range. But that could also have overlap, I think. Okay, wait. I'm moving on to E. I don't know why I can't get this. Question down. Which one is answered correctly? Which one is not? My student, he expects to get XI points for the test. Wonder how unexpected results could be. It is known. Number of questions, respectively. Oh, is permutation like the point values? Oh, okay. Hmm. Okay. It's one if an ICE student has answered the Jth question correctly and 0 otherwise. Okay, so we're essentially given... I got it. So it's like, I understand. So for each student, they're given some set of questions that they answered correctly. We don't assign point values to them such that this quantity is maximized. For multiple answers, we print any. And it's only 10 though, which is really weird. M is large though. Two to the power of 10 is it's 1,000. Okay, so what if instead we just say like we force some students to have larger values and some students have smaller values? Um, we can't really brute force on the questions themselves, but what if we brute force on something else instead? Or it's like if the first question is answered correctly, So this is for each student, and then this is... I mean, what if we just do DP? What would DP look like? Maybe something like... Number of questions. So for the first question, if we leave it alone, then we'll just get this state. If we add the question, then we'll get another state. So in one question, we'll get two states. And then in this next state, we can either choose to answer or choose not to answer it. If we choose, then none of these questions are answered. This one's answered. That doesn't work because it's like you can't really maintain a subset of these. If we want to maximize everything, then it's that. If you want to minimize everything, then it's that. What if we do like the minimum? If we iterate over every subset of students, then we can determine which ones, who do we want to maximize, whose scores do we want to minimize. And then if we do that, then if we maximize some score, minimize some other score, then for each transition, it's easy to figure out what the total contribution is. Or for each question. If we choose to include it or we choose not to include it. Okay, I want to try this. So it's T, N, and M. And then N lines, where it's just like whether you've actually answered it correctly or not. Wait, but it's more so just like, yeah, whose score we want to maximize and whose score we want to minimize. So for this question, what point value should we assign it? If we're assuming we want to, if we have some set, Wait, so N lines, each one contains which set of questions the student will answer right. Okay, so if we fix some students that maximize our score and minimize our score. If a student that we want to maximize gets an answer correct, then we want that to be a high point value. Otherwise, if a student gets it correct, then we have the minimum point value. Because all we care about is like the total sum of these point values. So if we do this, and then if we just sort these values, like for each question it has like a counting, like it has like a counter where it's like, it increases by 1 if a student, if you want to maximize it, -1 if you want to minimize it, 0 if it just doesn't affect the answer. Then we can sort these values and then that would be our permutation there, maybe? I think that's it. Alright, that sounds like it could work. And okay, these are expected point values. Then this is followed by N lines. Where each is M characters. Ah! I'm spending so long on this contest. I don't like it. Oh, wait, no. I want to maximize this. Okay. Oh, this is like them. So if it's for every mask, these n lines each contains m integers. So for each of the m integers, we get so I want to do this for so grid covers at I is equal to grid at IB. Oh no, B at I. Yeah, because B is a question. No, B is a student that answers this question correct. And whether they answered correctly or not. Like this. Or one left shift. Okay, so grid at B at I is equal to 1. It's either equal to 1 or 0, so it's like one left shift at this. Or one left shift at B. Because it's a question number. Or no, it's a student number. Right, okay. Grid at B at I. Okay, that's probably the most elegant way to do this. So we have covers like this. Big count of I. So we do this. So for each mask, we do a question. Okay, so a question. So this is a question ID. This is like the benefit. Do this, and then for each question that we do, we get the covers in the mask. Okay, so int maximize is equal to the big count of mask and covers at I. Big count covers at I. Minus maximized. new unit, question ID number. Wait, so what is the permutation? So question I has a score of this many points. So I plus 1, and then maximize minus minimized. Collection sort ls, and then long temp is equal to this. So temp. Oh, the score of each student. Oh, so these are like a question values. Long values, long goal. There's up to m questions, but each question. Yeah, so this is a question ID. If it appears first, then that means we want to give it the lowest point value. So values at ls.getI.id is equal to I. So those are the values for the questions. Long. Okay, what's a good way to calculate this value? Okay, so what if we did r minus this? So that ended up being, if we want to maximize this value, then we can maximize this score as much as possible, and then subtract r from it. Or we can minimize, but if this ended up being bigger, in a sense, that wouldn't affect it. If anything smaller, it wouldn't affect it either. Okay, so the best way we can compute this is we have the values, right? The number of things maximized, which is big count at mask, minus total n minus big count at mask. Whatever this value is. Oh, you know, for each student. So if mask contains this bit, then this is a value that we chose to maximize. Yeah, so if we chose to maximize this person, then all of our questions that are okay, so it's like the number of students that have this thing maximized and the things that have this minimized. So the number of students that have this maximized is, and this question covers these people. Okay. And so if this is something that we maximized, then we want to subtract array at B, right? Else we do this. Then these values, and then for each person, wait, but if it's like 10 to the, I don't want to do like 100,000 though. Will it run in time? Probably. Maybe, maybe not. Seems risky though. Okay, well, each question will have a mask of people who answered this question. Okay, so, and then 10. No. So, for each question, we add on Wait, should it just be some of this then? Wait, no, it's like we've assumed that we've assumed something already. The score should just be reflected by that. But we're just generating a set of scores over here, which doesn't mean yeah, okay. Yeah. This is just doing it without the absolute value. And like if the absolute value if it doesn't count for absolute values, it's going to create a worse example, which just means that that's not the best like mask. So yeah. I think this increases by, oh wait, but like if we increased by this, then we have to long values. Okay, well if it's n and then m. For each value of n in here, and for each question in here, temp plus equal to val plus equal to grid b times I. So if you answer this question correctly, then you get the score of I, and then val minus equal to array of b. If best is less than temp, then best becomes temp, res becomes values. Okay, we got E. I'm gonna try to see if I can speed this up, because I don't like that time limit. Wait. Hold on. I need to try to speed this up. I think this is a bottleneck over here. What's the best way to handle this? I think if we can do something like maybe you can use unit, because it's like this question will get. Let me try that actually. So I think it's if mask and so if this is greater than 0, then temp. And we need to maximize this value, which means that you need to subtract area B. Otherwise, we minimize this value. And so this needs to be up here. And so what we can do then is we can then do for each unit, let's do temp plus equal to ls.getI. This is a unit itself. And then we add on what do? We do temp. So values at u.id. So this is how much value this gets multiplied by this, which is like the multiplier. Let's see if this is a little better. Is that better? Not really, no. Huh. Well, I mean, it is O of n times m now, so it's only slightly better. How much input is there? Sum of m over all test cases does not exceed. I guess there could be a lot of input actually. Let me, hold on. There could be a good amount of input. Let me just use fast scanner. Yeah, I think I'll just use fast scanner and then just leave it. So we want to do fast scanner. It's slightly better. I'm gonna just leave it. And I need to charge my laptop. And I was looking to solve D. Those are a few things I need to do. Well. Okay. I have a feeling I'm just overthinking D a lot. What's like the obvious DP? Yeah, I'm definitely overthinking it. I'm gonna go to the bathroom. Okay, problem D. How do you do this? Oh, you can only do this operation at most once. Maybe that's what makes it easy. Because maybe instead we can think of it as like a prefix and a suffix that stays the same. And then it's like, how many ways can we do this? So if we choose a range, we're always arranging k of these. So these can go over here and these can go over here. So we put a 0 in here. Okay, so we get a bunch of ranges. If we get a bunch of ranges and then we just do this range on I. This way there's like two ways to do it. If we put it over here. So considering all the ranges, if we do, how many units do we want to place in here? Place X number of units in here. Okay, well if we put like number of ways to assign X of these positions in the first I. And then it's just number of ways to assign something in here, and any one of these. Yeah, because if your range looks something like this, then it's like you have one option here multiplied by one option here. But it also depends on which option you do. Or I guess it's like maybe, I don't know. Wow, D is really easy. It looks like it's really easy. Because a lot more people have it than E. Is it runtime for E? Okay, it is relatively slow, I guess. Let me check Java. Yeah, it makes sense. What if we construct every string and we determine whether this prefix is a possible prefix of what our current string is like? Wait, actually that might be the way to do this. Where it's like dp, we have this many number of zeros and many number of ones. This current zero, we need to just check to see whether this zero can reach this zero or not. I'm gonna try this. So, basically what I'm gonna do is, do we still need prefix sums? Yeah, we'll still use prefix sums. But I'm gonna do dp a little bit differently. So it's like int left is equal, int z is equal to 0. Well, okay. New int n. So for each location, so if input at A was equal to a 0, then we want to figure out where, like to the left and to the right, where it can go the most. So if we do something like left, it's like, can it go under? Like basically we'll take this range so min ones is equal to so min ones is equal to query p sums from 0 to, or I guess it's literally just this p sums at p sums to if r is less than 0, return 0. So from 0 to a minus 1. leftmost, because it can obviously stay at its own position. And count is equal to 0 for int I is equal to a minus 1. I is greater than or equal to 0, I minus minus. And so count plus equal to array at I, or input at I, minus this. And so if count is equal to k, then we know we can pivot up to there. And so then leftmost is equal to it's like, well, leftmost is the minimum number of ones that have to be to the left of the 0. P sums will query P sum 0 to A. Just query the number of ones. Otherwise, we do leftmost is equal to, then we'll be the one to 0 is a bunch of ones, but this one can go behind the 0. So query P sums 0 A minus 1. And then we break. And rightmost is A, or no, we'll query P sums 0 and A. And count is equal to 0. And then same thing over here. Except we go in the other direction. A plus 1, I is less than n, I plus plus. Input I is equal to this, if it's equal to k, then rightmost becomes this. And now we query something else, where it's like, if it can move like to the right by this much, then it's just 8 plus 1. Okay, so if L is greater than or equal to dp.length, or this. So if L is strictly greater than R, then we return this. Okay, if array at I plus 1, what's the number of ones to the right of it? Minus, what was the maximum number of ones to the left of it? We can do 0, and then I guess A. Yeah. I guess it's just A. Yeah, because if it's like 0, if k was equal to 1, then however many ones would be before here, it would be here. But if it was like here, 1, like something, it was here, something, 0, 1, 1, then it's like including that. Yeah, okay. So these are correct. And so left dot add leftmost, right dot add rightmost. New long left dot size is equal to 0 or left dot size is equal to n. Then the answer is just 1. And z is equal to left dot size and number of zeros, n minus a, number of ones. And so long dp is equal to long a and b. So dp of where it's 0 of 0, like there's exactly one way of doing it. So in sum is equal to 1. Sum is less than equal to n sum plus plus, or in a is equal to 0, a is less than or equal to a plus plus. b is equal to wait, for and a is equal to 0, a is also equal to a plus 1. When b is equal to 0, b is also equal to b plus plus. And so if a is greater than 0, then if b is greater than 0, and at the very end we'll do dp at a and b. So like this number is 0 and this number of 1s. Okay, so in this case we want to increase the 0. And so if left dot get at cur is less than or equal to b and b is less than or equal to right dot get at cur, then we can add this on where it's like dp at a at b, dp at a minus 1 at b, and if dp at a at b is greater than mod dp at a at b mod. Okay. If b is this, then it's just dp at a at b, dp at a at b minus 1. dp at a at b, same thing over here. Then we do this. Okay. Come on. Okay, that's not right. Okay. Why is this not right? Leftmost. Yeah, this is dependent on leftmost and rightmost. That doesn't look correct at all. Oh, it's I. I'm stupid. These are supposed to be I. Well, that's not right. But are these leftmost and rightmost points right? So this 0, it can end up over here at before these 4s. It can also end up as the first 0 to ever occur. Same thing over here. This 0 can be 2 to 4. Okay, so that looks correct because it's third 0. Yeah, it can never go before those. Yeah, so it's like the first 0. Yeah. dp at 0, 0 is equal to 1. Because like a blank string, there's exactly one blank string. Let me just make sure. I mean, this should be okay, but it's worth checking. Yeah. Like, how many valid prefixes are there? Maybe they're the easier one to debug. That's 1. That's 22. It seems to be consistently like like roughly twice too many. So if that's the case, the first zero needs to satisfy this. Oh wait, I guess consecutive zeros are a bit of a problem, right? Because it's like if we have, yeah, it's like if we add a 1 and then wait, no, but it's like, this is, we're just taking these valid sequences. Like how many sequences of currently this many zeros and this many ones exist? Yeah, so it's like if it was all 3 zeros at the beginning, like DP, that would not pass. Because it would be like DP at 3 at 0 should be 0. Okay, it is 0. Huh. Wait, so what if it's like we get some value and then what do we do then? So we get a number of ways to put a 0. They put the next 0 is a number of ways to put this up against here. What if it was like 3 and 2? That would be 3. Okay. What about 4 and 2? It would be 6. I guess because you could just rearrange. Yeah, 4 factorial over 4 is 6. Okay, 4 and 2. Or 5 and 2, I mean. Okay, so this changes nothing, this changes nothing. So this says we can get 3 ways to do it. I feel like it's more though. Because we could do, because obviously the initial string, we can do 0, 1, 1, 0, 1. We can do this. We can also do 1, 0, 0, 1, 1. Okay, so this is just, this right here isn't correct. Are these values correct for 5 and 2? Not 1 and 3, it could be 0 and 3. We're not calculating these correctly. Frick. Okay, so it's like if count plus query p sums from a to n is greater than or equal to k. So query at p sums. Wait, no, but then we could just like get some border and just cut it from here. Just take however much we need. Is pretty much what we're doing here. Because we know A itself is this, so it's just anything greater than that. Okay, and so if count is strictly greater than k, then we break. Otherwise we do this. Okay, so if count is strictly greater than k, then we break. Otherwise, if count plus query p sum 0 to a is equal to k, then we do this. Line 38. What's up with line 38? Oh, and -1. That looks more correct. What about this? Okay, that looks different. Even though I thought these were correct. 020224. Wait, what did I change in here? 020224. Huh. Okay, if left dot cur is less than or equal to b, and b is less than or equal to right dot get occur. Right? And we just add left dot add leftmost, right dot add rightmost. Yeah, because b can't be equal to this, or it can't be equal to this, so cur is equal to this. Mod this. No, okay. How do you do D? What is wrong with me? Oh my god. I just straight up don't know how to do D. Okay. I want to figure this out. Just like figure out where I'm being stupid. And yeah. Alright. Yar.